We're going to get into the best practices for rigging safety and accident avoidance. And we want to welcome everybody. If we missed your agency, we apologize. Hopefully we got you on here. This is truly an interagency briefing. I am really excited to hear what you guys think about this in the government because of just some of the things that we see in safety. I appreciate the folks from NIST here laying out those pieces. Real quick, just so you can participate, this comes from GSA. It's provided to you for informational purposes only, not legal advice, and we're not affiliated by any agency. And your participation isn't an endorsement to purchase from anybody. So there you go. We do love participation in the chat. You will find that we will put in these are the session docs that you can get to, as well as you can raise your hand and ask questions. We'd love to unmute and just have the dialogue. If you have any questions of Patrick, we'll give you an example of why you might want to ask him some questions in just a minute. Those session docs include the presentation as well as some of the guidelines and other federal guidance for safety for rigging hardware. So we appreciate you guys joining us today. And as far as why in the world did you decide to come to a rigging party? Let us know. If you're just interested in rigging safety, that's great. If you want to make sure you have the latest information, that's fantastic. Maybe you're running projects for rigging, or your boss made you come. Some Weisenheimer's going to pick that, Miriam. I am certain somebody is going to choose that for sure.
More than one, probably.
Well, I think you should have my boss/wife made me come.
Oh boy. See what happens? See what happens? You get a character here and you never know what's going to happen. And you can just send it to hr@govbrief.us and all the complaints can go there. And Steve Smith, as we have an upcoming rigging inspection contract. And Lewis is new as a division safety representative. Love that. So give us a little overview about TPH, knowing that you're founded in 2009, you're master riggers. That's what you do on a daily basis, right? That's what you're all about.
Yes, what we do in our company is based in New York City, and we erect tower cranes like the one in the picture here. We do the design work for tieback steel. We get the tieback. The tiebacks are those things you can see 1, 2, 3, 4. That's 5, I think, in this picture. It ties the crane to the building, and as the building climbs up, we attach the tiebacks to collars that are around the tower, and there's a whole mechanism for jumping the crane up. It's referred to jumping up and down. So we install the cranes and we take them out. We provide the riggers, we provide the operators. We do other regular rigging jobs. I was at Brooklyn Navy Yard for months. We're doing a precast garage. Columns were 120,000 pounds. I did the roof of the Arthur Ashe Tennis Stadium in Queens.
You did that personally, right?
Yes, that's a retractable roof. They found that because of the weather, every time there was rain, it cost them something like $17 million, because shows that TV stations that were showing tennis, now they had to break to something else because it stopped because of rain. So it made a lot of sense with a retractable roof. The thing weighed 220,000 pounds. It was an interesting pick, a single pick with a single crane. That was an interesting project.
I'll bet.
Yeah.
And you also, the Hercules crane, what is that?
The Hercules crane I designed from an existing design that came to New York City in the 90s. It was a company in Thailand that was set up by Scandinavian engineers. And I bought one back in the 90s, and then I saw a different type that I asked them to design and make for me. It comes apart, it goes on the roof of a building, and it hoists things up from street level. So when you get a building that's, and there was an example on Pearl Street in New York City, the building was very high and it was very, very tight. You couldn't the crane couldn't actually be set up because the streets were so narrow. So we brought our Hercules crane, which comes apart. We brought it up in the elevator, brought it to the roof, put it together, um, connected it to power. It's a three-phase 220 power. We have 2,000 feet of wire rope on the drum, and we hoisted everything from the street.
Wow.
Has a capacity of, I think the total capacity is about 13,000 pounds, but that's a sort of a nominal capacity. The practical capacity is 6,000 or 7,000 pounds when you go up.
Love it.
So,
And you also invented and the patented shackle technology with the super shackle. We're going to be talking about that. And Miriam, being the owner, is a woman-owned small business owner who is getting blinded by the sun right now.
Yes.
So,
Yes.
So there you go. So we're going to end this poll in 3, 2, 1. Any last-minute stragglers? 83% participatory in this so far. All right, let's share this out. I think this is really cool. So nobody's boss made him come. Nobody's a Weisenheimer here. That's the first thing, Miriam. Just saying.
Great. Okay.
So, but then it's 50-50. They've heard about centering loads on shackle pins, and 50% haven't. So this is awesome that we get to be able to help folks understand the importance of that, right? And then we have a few people that have been here before. We appreciate you guys joining us back. It's great to see you. And now we'll get into a little bit here. I'm going to give you introductions to Patrick and what he has been doing. Pretty cool stuff. We'll review some rigging safety standards. We'll talk about the importance of making sure that your loads are centered and mitigating the human failure, especially, right, Patrick? That's the biggest thing that we've got to be up against, right?
yes.
Give you a
Absolutely.
case study of this, and this actually happened just the other day. Was it you that got that picture, or was it one of your operators that sent you that picture?
One of the operators sent me the picture and said, "This doesn't look right. What do you think?"
That's right. So we'll talk about why it doesn't look right, and we'll look at some of the standards, making sure that the shackles are made to your standards, and BAA and TAA compliance is part of that too. So the reason why Patrick is here is this gentleman has been all over the place as an expert witness, and that's for all types of. When do you get pulled into the conversation? Why are they pulling you in as an expert witness?
Generally for accidents that are related. Right now, I'm involved in. There was an accident on the George Washington Bridge, where an iron worker, they were setting up. It's amazing when I see these accidents. I'm tempted to say to the plaintiffs, the guys that were hurt, "What were you thinking? Why weren't you thinking?" I've been. This is my 50th year in the business. I started my apprenticeship in 1973 in Ireland.
When you were 4 years old, is that what it was?
Yes. And I've seen, if it's possible to screw things up, I'm fully confident in any crew. I've had a ringside seat to some of the most spectacular screw-ups that luckily I can jump in and say, "Whoa, stop, this is not what we're doing." And very often, I've owned companies, union companies, non-union companies, and it's just amazing when I see some of these accidents, and I say to people, "But you had a drawing showing you what to do. Why did you change?" And they go, "Well, some white guy in a suit came up and said they were in a hurry and they needed to get this on the truck today and they don't have time to do it according to the drawing." And I'm like, okay, if that were me on the job, I'd say, I have a drawing that shows the way. There was a case at the trade center. They were taking down a structure that had supported a tower crane for rebuilding the trade center. And they deviated from the plan. The plan was good. They deviated from the plan, and these two ironworkers, Native Americans, they got hit with a beam that came down on them. And I'm like, number one, why were you standing there? And obviously, we can't berate the people that are paying us as an expert witness, but why were you standing?
It sounds like you're doing a good job of it.
Yeah, why were you standing there? And don't you know how gravity works? As a structural engineer, I have to be familiar with the laws of physics. You're struggling with the laws of gravity.
Oh, my gosh.
The stuff comes straight down. So, generally, when we look into accidents, it's shocking the level of and the layers of stupidity. And accidents never happen for one reason. It's generally compounded by two or three different things happening. And, I see it I was a pilot, I see it with flying. Accidents never happen for just
one reason.
One simple thing going wrong. It's a combination. And I tell people all the time on a job, okay, there's something minor is wrong. Let's say, for instance, the safety latch on the hook is broken. Fix it. And I thought that important. It could be one of the factors. And
Right.
when you have an accident, the likelihood of an accident is actually the factor. If you have four things wrong, you're not four times as likely to have an accident. It's the factorial of 4 multiplied by 3 multiplied by 2. That's 24 times. So by eliminating just one thing, you reduce it to 12, a factor of 12. So I'm constantly telling people, fix the little things. If your radio isn't working properly, get a radio that is working properly, because the operator may not hear. You push the button and it doesn't cut in right away. Just fix the little things. And I see it all the time. And it's just that I had a structural engineer who qualified in Queen's University in Belfast, and he came to the US and he came working with me, and I sent him out in the field as a project manager. And he said to me, I'm shocked. I'm shocked at the level of non-conformance with basic safety standards, and the level of stupidity in the field is stunning.
And so what we're going to be talking about today, hopefully you're going to help us with what to do, what not to do, and how you can mitigate some of those. I'm telling you, I love to hear these things, and I'm always fascinated because this is the first time we've done this briefing. So tell us, what is your role in rigging? And do you specify it? Maybe you're the engineer of record. I didn't even know that was a term until Patrick told me. Purchasing, safety manager, rigging supervisor, or maybe you're the rigger signal person, or maybe something else. And if it's something else, pop it into the chat so we know what that other thing is, because I want to make sure we understand what it is we can do best for you. But we're going to get right into the rigging safety standards, and you can see some of the issues on the right-hand side. Now, tell us about these standards real briefly. We have these in the handouts. For those of you who just popped up, I'll put this into the handouts again. But tell us what these standards say, and then just synopsize it for us for the performance standards and some of the best practices for folks.
Well, under ASME B30.26, that's the part that specifies shackles. They say that shackles have to have a 5-to-1 safety factor. In other words, that it can withstand 5 times the rated load before it rips apart. So we test shackles by sending to a testing lab, and they physically test them, but they apply the load to the center of the pin. Just like on the left, you can see there's a shackle and the hook is in the center. There are washers on either side, because the load is being distributed equally to the shear plane on the left and the shear plane on the right. But now, when you're in the field and you have a condition like on the right-hand side, now you're not distributing the load equally between the left and right shear planes. All of the load is on the left side. So it means that you're actually violating that 5-to-1 safety standard. You now do not have a 5-to-1 because you're putting more load. Let's say, for instance, in a 10-ton shackle, we put the load in the center of the pin. Now there's 10,000 pounds, 5 tons goes to each side. But if you allow this to happen, and you'll see in one of the pictures later that it does actually happen, now you're loading one side maybe 75%, and the other side is only seeing 25%. So where the test factor 10,000 pounds going to the left, you're actually applying 15,000. So you don't have a 5-time safety factor there. So you're eating into your safety factor.
And you never want to eat it into your safety factor in any way, right?
Absolutely not. I mean, it's in the event of anything happening, God forbid, when they start investigating and find that you had violated that 5-to-1 safety, that's a big problem. And
that is a big,
like I say to people, it's not a problem until it becomes a problem, but when it becomes a problem, it becomes your problem.
So much. Let's take a look and see what folks are doing here. So we have a couple folks that are doing the specifying. Some are doing the purchasing, safety managers, supervisors spread across there. And we have the others. Let me tell you about a couple of the others. Russell is an observer slash construction inspector. Very important to have that, right? And for John, he's a sprat technician, and rigging goes hand in hand with rope access. I don't have any idea what a sprat technician is. Hold on a second. Let me see if I can get John to unmute for just a second. John Archibald, you there? Did you get unmute for a second and tell us what a sprat technician is? Do you know what that is? Anybody else? You there, John? He can't find the unmute.
Oh,
there he is. Go ahead, John.
Go
ahead. Yes, sir.
Can you hear me?
Yes, sir.
So SPRAT is Society of Professional Rope Access Technicians. So basically hanging on ropes and accessing places where you otherwise can't. So a lot of the same principles, load sharing on anchors. You don't want to overload one side. You want to actually be sharing a load kind of thing. So yep, sprat.org. There you go.
There you go. Russell, also fellow spratter, apparently, John. That's awesome. So you may have seen some of these things happen before, right? In some of these.
Some of these situations, yeah, like figure 2 right there with it. That's a pretty low angle.
Yep. So
to reduce the capacity of your shackle, reduce the capacity of your overall system. So
absolutely
similar.
So yeah, man, I appreciate you joining us, and I learned something new. What a sprat was, man. That's awesome. So
thanks for having me.
This actually comes from the patent that you had provided, and the importance of this, right, Patrick? That you need to be conscious all the way across the board about how you're displacing your load, right?
Absolutely. On every rigging drawing, every rigging plan, it will tell you to keep the load centered on the pin to avoid the figure 4 situation where you have to decrease and you're overloading the shackle. And as John said, I think John, he said, it happens. It happens. And you have to center it. Now, there's a few different ways of centering it, but they're all very, very cumbersome in the field. And if you're in the sprat world, you're up on top of the building and you're ready to get going. That's you're not going to start putting washers on either side of the shackle pin just to center the load.
And using gloves, right? So we see these wintertime in New York City can be a little bit brutal, right?
I'll say, and try on top of the buildings 1,000 feet in the air. That's absolutely brutal is the word. That's
right. So when you have your folks down in the field that are doing the work, which are awesome, right? They're down there. They're trying to accomplish the mission of attaching things and getting them up on the top. And a lot of times there's pressure, right?
Absolutely. Time pressure is huge because the cranes are hugely expensive, and crane time is the most expensive time on the job site. And
so you have lost components. You can see there's different ways to be able to center that load. You have a centering. What do you call that? Like a washer? There's washers, obviously. What's the other part?
That's a spool.
The spool. I got you. So the spool, so that can help center it on there, but then you have parts, and sometimes the parts aren't right for that particular shackle. Is that what you're saying?
Absolutely. You have spools, but then you have different size shackles on a job. So now you're telling the guys, okay, I want you to bring out 3 different sizes of spools and put them on the pin in order to center the load. It's impractical. There's so many ways that it can fail. You got the wrong size spool. You got the spool doesn't fit. You drop the spool. It's just another thing that you don't need to have to do out in the field. And
especially that bottom part, which is there's nobody that's the design engineer that's specified that's there to take a look at what's happening.
Exactly.
Because their job is they do the drawings. Worker's job to follow the drawings and instructions, right?
Absolutely. The engineer record will or whoever does the rigging plan will specify what's to be done. But then the oversight is the foreman in the field who's being pressured, get it done, get it done, get it done. So there's nobody there to police them and make sure that they're following the plan. So great.
we do see, if you take a look, there's where that's a shackle that was not properly utilized, right?
Yep.
Either underrated or otherwise. And then you also have problems with the rope, right? That we're talking about. This is and being able to have that, when you have a problem, like you said, it may not be one single thing, but it then starts to compound because you'll start to have problems with the rest of the hardware too. Now tell us about this. Now you created the super shackle, right? So
Yes.
one of the things that you wanted to address actually is done by this barcode, right? If you take your phone, if everyone wants to take their phone, you can actually go up to it on the screen and it'll take you right to the specifications for that shackle. It's really cool. And that's included on. Why did you wind up doing that?
Well, when we get a batch of shackles, generally 2,000 or 2,500 shackles from the forge, we take 3 of them and we test them with a third party. Well, we don't have the forge test their own shackles, so we test them. We take three random samples. Then we get the test report. We send it to a company called Modern Industries in Erie, Pennsylvania, extremely impressive testing agency. And they send us back the report. I then generate a QR code, a circular QR code, and we attach that to the end of the pin of the shackle. So at any time, anybody in the field, a safety guy, one of the riggers, signal crane operator, he can go right up to that with his phone, check it, say, okay, I see that this, I see the test results of all 3 shackles that were tested, and the proof load of 2.2 times the working load was applied. The pin could be removed by hand after the first turn, and I see that it broke at greater than a 5-to-1 multiple of the rated capacity. So typically, if you want to get that information, you'd have to get onto the manufacturer, like Crosby would be a favorite, and they'll charge you. They'll send you the test data, but they'll charge you for it. But then how do you know that that's the one for the particular batch of shackles that you have? This way, it's an added feature that it gives you the reassurance that, yeah, I got the test data.
So it mitigates the making a mistake on which shackle to use and making sure that it's rated properly, right? The other part that I really find interesting about what you have, that this is part of your design, right? And the idea is to use a pin that automatically self-centers. That's what the patent's for, right?
Correct. So
so the biggest problem that we see is folks that are down on the field trying to get the work done. They're doing the right thing by trying to get the work done, right, Patrick?
Yes, absolutely.
But that's when you wind up having some problems potentially. So tell us about how you came up with this and what you want to solve.
Well, I've seen for the last 30 or 40 years on every rigging plan that I've had that it tells you to center the load on the shackle pin, on the pin, but nobody ever does it because it's too cumbersome. You're out there, you're wearing gloves. It's just another thing that you have to take care of. It's not that important. I spoke to an engineer, a good friend of mine, and I said, have you ever specified? He said, I specify it on every rigging plan. I specify, keep the load centered on the pin. And I said, have you ever seen it done? He said, nope. Never seen it done. So I thought, well, okay, the guys are well intentioned. They're out there and their priorities are like production, go, go, go. And like we'll see with a photograph I got recently from one of our operators in New York City, they don't have the full breadth of knowledge that the engineer of record has or the master rigger, and they think, oh, okay, we don't need this little part, this spool, let's just go with it. And it allows decision making in the field that shouldn't be there. So having a pin like this, I like to call it idiot proof. It's not possible to screw this up. There's only one way it goes in. And you can't possibly screw it up. I designed a taper on the back of the threaded part, and that gives us a little bit of bearing to help out the shear plane And it actually improved the performance by 25% when we did it. We tested it in the foundry. So, and also the capacity of the particular shackle is matched to the radius of the depression in the center of the pin. So if you're using the correct size choker, it nests in there very nicely because the diameter of the choker and the diameter of that depression are the same. For instance, if you're using a 10-ton shackle, a 10-ton choker is 1 inch diameter. The radius of that depression will be a ½ inch, so the diameter will be 1 inch. So your 1 inch choker sits nicely in there, so it doesn't flatten. I've noticed over the years that chokers get flattened from going over a straight pin. So this is a big help. Though there is another way of solving this. You can use a choker with a thimble, but that costs more money. But this does the same thing as the thimble, and it doesn't cost more money. So that's another feature of it.
So gotta love when engineers who are actually in the field, actually using stuff and seeing things working, when that creates, necessity is the mother of invention, right? So now this is a reason why. So if we take a look at this is one of the pictures that came from your folks this week, right?
Yeah. One of my operators sent me this. We put up a tower crane. Now this is a balance weight. When we're jumping a tower crane, when we're moving it from the elevation it's at, and we're increasing the height, the crane needs to be balanced. You have a counterweight on the back of the crane, which tends to, if the boom of the crane is all the way up, the counterweight tends to want to pull you backwards, and it may be as much as 14, 16, 18 inches. So we can't climb the crane when we have that load moment, pulling you back. So we use a balance weight, which is maybe a multiple or a factor of the counterweights, and we boom down to a certain point. The guys that are in the climbing frame will tell you there are wheels on either side for guiding the rollers, and they'll tell you, okay, it's balanced now because the roller is loose front and back, we're good to go. So now this 17,600, so the guy took a 10-ton shackle. So you say, okay, 10-ton shackle, we're good for 10 tons, 20,000 pounds. 20,000 pounds is more than 17.6, we're good. But you can see the wire rope has slid to one side of the shackle. So now, instead of having 10,000 pounds transferred to each shear plane left and right, you now have 75% of the load is on the left. So now, instead of 10,000 pounds, you've got 15,000 pounds. You're overloading it by 50%. But the guy on the ground says, hey, it's a 10-ton shackle. The load is less than 10 ton. We're good to go. So that's why here, having the guy in the field, giving him the responsibility to understand all of this, it's not going to happen. So you can see how something, if you look on the left, there's a loss. There's a loss of capacity. Now, you're still good, but you've taken your factor of 5 to 1, and you're down to maybe a 2 to 1 or a 3 to 1. So you're nowhere near the safety factor that you're supposed to have. Now, on this, you have a static load. You pick it and it's static. But when you have a dynamic load, let's say, for instance, you have a load that's tied down on a truck, or you have a load in the cargo bay of an aircraft. Now that's a dynamic load because with acceleration, with G-force, you're increasing, you're decreasing. So it's really important not to compromise by being off center with the pin. So that's why we have, if you look on the right-hand side, we have a depression in the center of the pin. The wire rope goes in that depression, and it just is not possible for it to slide. So it's automatically distributing 50% of the load to the left shear plane and 50% to the right. The shear plane is the plane where the pin meets the body of the shackle. That's where it's going to shear under destructive load.
And as you mentioned, there's a lot of ways that they're working to mitigate this and make sure that things are centered on the shackle, between washers and what was the other spool, right? That you mentioned.
Yep.
And the idea is to make it, like you said, idiot proof. So now this is a product that you created. So we just want to let you know what's happening and the reason why you did it, because you're a crane operator. You're seeing these things after the fact. You're up, 500 feet in the air, right? And
Correct.
you're seeing the dynamic loads coming up, and you're all of a sudden you don't know that that's even this way until it's already 500 feet in the air.
Absolutely. Generally, the crane operator is he's a more qualified individual, but he doesn't get a chance to put his 2 cents in. If you tell the guy downstairs, listen, I got these spools or I got these washers. Now, when we pick up a balance weight, every time we jump the crane, each phase, and typically a section will be a 6 meter is 19'7". They're generally European sizes. So every 20 feet, you're going to put down the balance weight. You're going to pick up the next section. You bring it up. You bring up the next section. You put it on either a tray or a trolley beam. Now you have to balance the crane before you start your cycle again. So now you have a guy down there, and you're going to tell him, okay, every time you do this, I want you to pack washers on either side of the pin, either side of the wire rope to keep it centered. And typically on a day we'll jump, maybe between 5 and 10 sections, depending on circumstances and the length of time we have on our permit. So, typically 7 or 8 times we're going to tell this guy, okay, every time you pick the balance weight, we want you to do this. It's giving an element of discretion to him that we don't want him to have. We want to give him a shackle that says, just screw the shackle pin in all the way, you're good to go. You don't have to think. And generally, they don't disappoint us in that area. They don't think.
So, which is why you wind up in courtrooms from time to time.
Absolutely. So, and it's
the idea, as you said, is mitigating the human error, making sure that what needs to be done. And this is simple. It's not complicated. It's 2 pieces that screw together and you're done. And if you're not sure about whether or not the unit can handle it, you can hit the barcode on that, or
right.
QR code, I should say.
And the capacity is also right on there. It tells you that you see on the right hand side, it says 3/4 high strength. And because we manufacture and we test to military spec, to the RRC 271H. That's a military spec. There are two grades. There's an A and a B. The B shackle is the high strength. That's the only one that we produce. We don't do the lower strength one. On the left, working load limit is 10 tons. It also gives a quick indicator of a 45-degree angle, because as John said earlier, John the Spratt guy, there's a reduction that you have to apply when you're at 45 degrees or anything that's not centered. So it makes it, there's really nothing can go wrong with this. If you don't screw it in all the way, obviously that's a problem. But I think most riggers understand that you have to screw the pin in all the way. That's the only thing that can go wrong.
Yeah. And I love the QR code and being able to go take it right back. And and you mentioned this as well, that this is part of the reporting that comes back, that you're like, okay, let's make sure that all things from end to end can be represented without having anybody in the middle change their mind on what it should be, right? That's the whole idea. And you mentioned this before. What's that? Go ahead.
And also, when your specs say that they want to use best practices in the rigging industry, nobody can argue with you that this is best practices. The regular shackle has been used since Roman times. It's 2024. This is the 21st century shackle. We've abandoned the Roman methodology. And this is, so when somebody says we want you to employ best practices, this is absolutely it.
Love it. And real quick, you're just letting folks know about BAA and TAA compliance. If you're buying it for federal use, this has changed over the past couple of years. It's 60% now. It used to be 50%, went up to 55. Now it's 60% now, and this year it'll be going up to 65%. I haven't seen when that is. If anybody knows what actual date that would be in 2024, we know that it's happening in 2024. These are the initiatives that are out for us, and then 75% by 2029. And yours solves all that because you're manufacturing
But
here in the United States.
I've also heard that if it's made of steel, it's got to be 90% BATA compliant. But we decided to bypass all of that, made in USA.
Yeah,
It's-
so
it's a
I believe that
foundry-
it's 90% and then 95% if it's structural steel for use in structural steel. I don't know if that applies to this or not. That's a great question.
No.
I'm not a lawyer. I don't even play one on TV. So
Well, I do have a lawyer, a consultant on the BATA, and after being over and back, it's cheaper to produce overseas. But I decided, you know what? In our business, made in the USA carries a lot of weight, and I figured, what? There's a foundry in Wisconsin I'm dealing with. There's a foundry just outside Chicago. They're excellent, and I think that it gives me a comfort level when I'm out rigging. I always want to see Crosby. Well, up to now, I want to see Crosby. Now I want to see, I want to see Tarrant. And Crosby does sell spools to go over their pins, but the spools are not aligned with the pin sizes, so there's a disconnect there. But yeah, I want to see made in the USA when I'm out on a rigging job.
I love that. Anyway, this would be, I think everybody else here would agree with that too. So like you said, 21st century, you're not back in Roman times, removing the human element, and you actually have a lifetime warranty on this. So, and it meets all the US standards, all those pieces, third party tested the whole thing. And also for folks that are in the procurement side, if you want to pass this on to your contracting officers, it meets the FAR 6.302-1, which, because you have a patent, you can specify it and include it with the justification and approval documentation. And I highly encourage for folks that have not been here or seen anything quite like this, there's a lot of folks that didn't even know about it, right, Patrick? If you want to participate in this, hold on one second. Where is my final thing? It is not working. Oh, here we go. What you would like to do, if you'd like to get some samples, you can do that. If you would like to discuss a rigging requirement, where Patrick is here, he can talk about other things outside of this if you'd like to. And if you'd like to talk about a blanket purchase agreement, I'm sure that they would love to hear about that for your procurement folks. If there's anything else that you would like to do, if there's anybody want to, you can raise your hand or you can pop a question in if you'd like to, while you have a subject matter expert. Before you have to put them on the witness stand, you got them right here and you can ask some questions if you'd like to. And I appreciate, John, you coming out with the Sprat components. Anybody got any other questions or suggestions or recommendations for Patrick for what he can do to help advance the cause of safety using shackles? We'll be glad to discuss that. There's a couple folks that do want to get some samples from you to test them for themselves, Patrick. So we love that. And for folks that are here, you will get a copy of the video recording, the session docs, which I'll pop in right this minute, just in case you want to gain access to those before we even leave here. You can also have one-on-one meetings with Patrick and Miriam and those samples, and you'll send out actually 8 samples, right?
Yeah, well, we're sold out right now, but we have another batch being forged. It's probably I can't say how quickly we'll get the next batch in, but yes, we're forging 4 sizes: 3/8, ½ inch, 5/8, and 3/4. I'll send you a pair of each and check them out. See if you like them. If you like them, use them. Order some more. If you don't, you have free paperweights.
There you go, free paperweights, just in case. So that's good. So we do want to get you guys out of here. Appreciate you joining us. If you have anything that you need, there's Patrick's information. There's Miriam. Miriam talks too much in these briefings all the time, but we appreciate the fact that I love that you are in this industry. Miriam, when did you get into this industry?
Oh, gosh, that's many moons ago, but I really got into this industry back in 1977, actually.
That's awesome, because you're a pioneer. because
Yeah.
not a whole lot of women in
No,
this world.
there definitely were not a lot
Is
of
it
women in
is
the
it getting better
industry then.
now, having
Huh?
more women in the industry, or are you pretty much?
Oh, yeah.
fine, so-
Oh, yeah. Now it's a much more welcoming place for women construction. But yeah, but it's been an evolution, a slow evolution.
I can imagine so. So we appreciate that. If we don't have any other questions, we appreciate you guys joining us, especially folks that are doing this in the field. I'm hoping that this was beneficial for you. We kind of honed in on some very specific issues that can be created by not having the load centered on shackles. Simple thing, right, Patrick? Simple.
Yeah, yeah, but you know what? When people start researching accidents like this, aircraft in this Max 8, like the DC-10, they had a bolt on a door that would indicate that the door was closed. I mean, that was a tremendous tragedy, and people don't find it, and then when they do find it, oh, you know what? That was so obvious. And people, I've given these shackles to people, crane companies like Bay Crane in New York City. They're a huge crane company. They love them. The guys are like, give us more. We're constantly sold out because they want more. Give us more sizes. They want us to go up above the 3/4 sizes. So we're working on that now. But they love them because they see right away. It's like, oh, and the test of a really good patent is people look at me and they say, nobody thought of this before.
That's right.
There you go.
It only took what, 3,000 years or something.
Yeah.
When did the Roman Empire start, I guess? And who knows? It might have even been the pyramids for all we know.
Mhm. That's right.
Yeah, we don't know how they got those stones up there.
That's right. But they're probably using self-centering shackles to do it, and they just lost the technology. All right, guys, we appreciate you all joining us. I'll end that poll. We'll get you guys out of here. Great stuff, man. I learned something new for myself, and I'm hoping that folks here learn some new things too. And simple answers. Simple
Get in
answers.
touch, guys. If you need anything, just reach out for me. You can get hold of me anytime.
Yep. And there's several folks. I think there's like 8 or 9 people that said they wanted samples. So we'll make sure we get through those folks, and you can get the addresses from them. Get those out to them. I'm really interested in hearing what the Govies think about it, because you weren't thinking about it till you popped in here. We appreciate you guys joining us. You're welcome, John. John says thanks, Patrick. Really appreciate it.
Yep.
So we'll keep the conversation going. Spread the word a little bit. Help these guys help your safety work on the jobs. You're welcome, Tim. All right.